I hope I'm audible to all of you. Am I audible?
Yes, sir.
Okay, great. So let us start with today's session. I see 12 of you have already joined. And let me just share my screen with you. Okay. Is my screen visible to all of you?
Yes, sir.
Yes. Okay, great. So last hands-on session we had seen the basic commands which we are using in MATLAB, and today we'll be looking at how we start with the looping, or how to form a particular matrix or any other form in terms of loop. So we'll understand how the loop works, how a loop under another loop works, and how we can form these particular set of commands which helps us in looping. What is the syntax? What are the other parameters which we use for particular coding in MATLAB is what we'll be seeing in today's session. So I had also shared a doc file with you, if you can recollect, which had 5 experiments into that. So let me just share that file again with you. Uh, in this, I think we'll start. We have done the first 2 practicals. I want you to start with the 5th practical, which is to perform the diagonalization method for solving of matrix and eigenvalue. So, does anyone recollect what is diagonalization? Diagonalization method for solving matrix. Is anyone aware about this? Yes, no?
No, sir.
Okay, fine. So, diagonalization of a matrix is my screen visible to all of you? Can you see the paint screen here?
Yes, sir.
Okay, fine. I'll just enlarge the screen so that. Okay, or we can also use the whiteboard of this particular app. Fine, anyways. So let's say we have a matrix. And as per this, you have in the first row, you have 1, 1, 3. So let's take this as 1, 1, 3. In the next, you have 1, 5, 5. So here you have 1, 5, 5. And lastly, in the third row, you have 3, 1, 1. So that is 3, 1, 1. So this is the particular matrix which is provided to you. Now, if you want to find out the eigen values, so how you do is you take another identity matrix of the same dimensions. So another identity matrix would be where you have another identity matrix with the diagonals as 1 and the rest of the terms would be 0. So this is how you get the identity matrix with the diagonals as 1 and the rest of the element 0. You multiply it with lambda and you subtract this from this. So basically the formula is you find out the determinant of, if you name this particular matrix, let's say I name this particular matrix as A. So in that case, I have determinant of A minus lambda I would, and this is equal to 0. So once you solve this particular uh, determinant, then you can find out, after solving this particular equation, you will get different values of lambda, or say you find out different roots of this particular equation. Is nothing but the different values of lambda, which are nothing but my what do you say, eigenvalues. So here what I want you to understand first is that if this is the matrix, or let's say if I come back to my uh, MATLAB window, here I want to enter this particular matrix which has been asked here. Okay, but I want this matrix, let's say if you want to change this value, then I should be able to I want to make a program in such a way where I want my user to enter the particular values. Okay, let's say this is a 3 cross 3 matrix. For example, let's say I want to make a 2 cross 2 matrix, or let's say I want to make a 5 cross 5 matrix. In all that cases, I should be able to ask my user to form the particular program. So I want to design my program in a manner where user has all the rights to dimension, to decide the dimension of the matrix, to decide the value of each element of the matrix as well. Okay, so for that, what we need is, we need a particular loop which can identify that how to place these particular values in these particular rows and columns. So again, for that, I need two things. Either I can go row wise or I can go column wise. So here what happens is, your MATLAB is always fills your value column wise. So that means in the first row, it will fill all the values of the column. Then it moves to the next row. Then it fills the value of all the columns. Then it moves to the next row and so on. So initially, if I say that this is how my, uh, let's say first I ask that I need an input. I'm using the word input here, and then I can enter anything which I want this to be displayed to the my user. So if I run this, my first thing, let's say, okay, let us run this first. If I run this particular code, so see here it has, this particular block is right now at row number 3. So this is what it is asking me. It says enter the number of rows of the matrix. So when I use the word input, it asks the user that how many amount of rows you want to enter. So as per the question, we have already been given a matrix. Okay, so here the number of rows, that is first row is 113, second row is 155, third row is 311. So here the number of rows that we have is 3. So here we'll mention the number of rows as 3. Okay, now in this particular 3 rows also, you need to fill up values at 3 particular places. Okay, so you need to know the number of columns also. Okay, fine, you understood that there is, see, this is a 3 cross 3 matrix. You can also have a 3 cross 4 matrix. You can also have a 3 cross 5 matrix, 3 cross 7 matrix, or it could be anything. Fine. So here when we are talking about diagonalization, it is only possible for a square matrix. But even other than that, for any other use also, if you want to generate a matrix, it can have n number of columns. So you need to understand that you need the user to make the matrix. So for that, you also need the user to tell you what is the number of columns that you require. So here, my second is, that is NC, which is I want my user to input. What is the input required? Now I can write here anything. Let's say number of columns or only columns, or this is in my command. I can write anything. It will not change the output of the program. Now, this is something that you need to understand. Anything that you write within the inverted commas, that would be displayed, but that would not affect the working of the program. Okay. So here what we have entered is the number of rows, which was 3, and now coming to the number of columns. Here again we are entering this as 3. So now what happens is, now the magic starts. It says for now, see here, I is a particular variable which I have selected, where it moves from 1 to 1 colon 1 comma nr. Can anyone explain me this? What does this 1 colon 1 colon nr mean? We had done this in the last session. What does this colon represent? Can anyone try and answer this?
Sir, it indicates the starting point of a loop. After that, second value indicates how many steps we have to take, and third value indicates the ending part.
Perfect. So, Rohan, what you said was absolutely correct. So, friends, what we hear, what does this indicate is you start from my first value, and here you are talking about NR, that is the last row. So, here my I indicates that it will work for the number of rows. Okay. I, it is not religious that I would always indicate row and J would always indicate column, or K would. No, you can use any particular variable anywhere, but you need to use it in a way so that the MATLAB program is able to understand that, okay, this particular variable is used for either rows or columns. So here if you see, it is 1, so its starting point is 1. It would, after you complete this loop, then there would be an increment of 1, okay, which is this particular one, and then it will reach till increment, and the last value it will reach till is the number of rows that you have input. So in our case, the number of rows is 3, so this would increment till you reach 3. Now, the question is that what is this gonna ask us? So, okay, fine. If I say, if I run this loop, it starts from 1. Even if I don't use this, the center 1, it is an indicative that has the default value of 1. So, even if I write 1 is to NR, it would increment by 1 itself. But this is just for your understanding that we have placed this colon 1 extra. Is this clear? Am I making sense? Any doubt so far? Now we are entering into the loop. So if anyone has any doubts, please ask, or else we'll start the looping part. Okay, fine. So now let us see this. I have entered year 1. So my loop starts from 1. So from the first row itself, I am entering into, now see, this is, again, let me come back to this particular screen. So now here what we are doing is, okay, so now I am forming a matrix I have already been asked what is my number of rows, what is my number of columns. Now I am starting row wise. So in the first row, this is the first row where I am entering values. That is in the first row, I have again another loop here. It says from j is equal to 1 is to 1 is to nc, where 1 is the starting point, increment as Rohan said, uh, yes, as Rohan said, it again increments by 1 and nc is the number of columns. So it would ask the values from 1 to 3 and it will ask me that what are the values. Now let me just start showing you the output as well. So see, right now I was asked the value of NR, which I have placed as 3. NC, the value is placed 3. Now here it says enter the A percentage D element. Now this first percentage D is for the value of I and the second percentage D is for the value of J. So that means it is asking me here initially this particular, right now the value of J is 1 and this entire loop is under another for loop of I. So right now the value of I is 1. Right now the value of J is also 1. So here what we are talking about is, we are talking about this first position which is 1 1. So for this position, if you look here, the value is 1. Okay. So here the value is 1. So we'll substitute this value 1 in our program. So here I just simply need to mention this as 1. So if you see here, it says enter the value A11. Now the element A is turning out your first element is 1. Am I making this clear? You have entered this particular value. Now understand this. You have completed this loop Aij, that was your 1 1 value. You have inputted that particular value and it has been reflected. Now see here you saw that it was saying enter the number of columns. Here there is nothing been mentioned here. So nothing came mentioned here that enter the value or something. So here you are simply shown the cursor and you entered your value as 1. Now ये loop एक बार चल गया है. Understand? You have run through this loop once. Now what you do is after this again you come back to this particular point. Once you are through with this particular loop till you reach NC, then you will come again to the outer loop. So again, once the inner loop is concerned, you have done this for 1. Now you increment this by 1. So now the value of J is 2. So if the value of J is 2, now you have to enter the value of percentage D element where I is still 1, but J is 2. So now you have to enter the value for A12, which is, see, it is asked here. Enter the element A12. Okay. Now here Aij, you need to input the, so here, if I click, my cursor would be here, which says I need to input this particular value. Now again, let us go back to our Word file where my matrix is 1 1 3. Okay, so my second value of the matrix, that is 1 comma 2 is 1. So I'll again enter the value here as 1. Now understand this, that this particular loop that we are talking about, I started with 1, then I incremented it by 1, I wrote the value, it ended here. Again I am at the starting of this particular loop. Now the value is further incremented. So from 1 it went to 2. Now from 2 it will go to 3. So now here the value of I is still 1, but the value of J is now 3. So it asked me enter the value A13 of this particular element. Now again, if we look at our matrix which is given to us in the question, at 1 3 the value is 3. Okay, so we'll simply substitute the value here as 3. So now you can see that for A, the matrix A, my first row 1 into 3, that is 1, 1, 3. Now I have completed this particular loop. I have reached the last limit. Now once I end, so that means it will come to this particular end. It will again go back to this particular loop. So now for I, which was 1, I have calculated all the values of j. Now what is done is, now I see an increment in I. So if I see an increment in I, so now from I from 1, it increments by further 1. So the value of I now becomes 2. Any doubt here so far? Anyone? Are you able to follow what I'm trying to say? Yes or no? Please. I need a response. Are you understanding what I'm trying to say?
Yes, sir.
Okay, fine. So now we have, for my first value of I have calculated all the values of j. Now moving to the second, incrementing the value of I. Now my value of I is 2. So if I see here, I'm been asked for my value of I has been 2. But now in the loop for I also, I have another inner loop for j. And for that, j starts from 1 and goes till 3 with an increment of 1. So again, for I is equal to 2, my value for j, which is equal to 1, I need to enter the particular element. So this I value is 2, j value is 1. So I need to enter the value for the element A21. Is this clear? So now let us look at the value at A21 is still 1. Okay. So here the values are 155. Please remember this, so I don't have to come to this particular page again. Okay. So here, see, here also it will show you that which loop you are running as of now. Okay. So this is also another indicative. Now, here if you see, for the value of A21 is 1. So let us enter this value 1. We place an enter, and then now you are done with this particular loop. You have entered the value. The loop again comes here. Initially your value of j was 1. Is there a scope of increment by 1? Because you have still not reached the final value. Yes, you have the scope of increment. So now the value of j becomes 2. I is already 2. J becomes 2. So I have been asked to put the value of A22. Again, your second row was 155. So I need to enter here 5. So here you can see my 1 is there, my 5 has been entered. I have not entered any value here, but it would always place the entire row value. So that is why this place is placed right now at 0. Again, my this loop again ends here, but again I have a scope of increment in j, since j is 2 and this can go further till 3. So again I have a further increment in this. So now the value of j is 3. So value of I is 2, value of j is 3. So the element you need to enter is A23. Now, as we know that your second row, the values are 155. So I need to enter another 5 here, which makes my second row elements as 155. Okay. Now we are done with this particular loop. So 1, 2, 3. Now I cannot further increment the value of j to 4 because the limit is from 1 to 3. Okay. So once we end this, we again end this. So this brings us again back to the for loop for I. Now the value of I right now was 2. Now I need to further increment by 1 because I have not reached the final value. Okay, my final value of NR was 3. So I further increment this 2 to 3. So once that is done, again for third row, I need to enter the values for each column. So for J again 1. So So this would be 3, I value is 3, j value is 1. So for third row, first column, the value is what I need to enter. Okay. So let us again look at the question. So for the third row, the value is 3, 1, 1. So third row, first column, the value is 3. The third row, second column, the value is 1. And the third row, third column, the value is 1. Okay. So again, coming back here, so the value of A31 is what I need to enter. So A31 would be this particular 3. Okay. So I'm entering the value here as 3. So you can see the value of 3 has been entered here. So now again I am into this particular loop where the value of j was 1 has been done. We came to end. Now the j is incremented to 2. So now the value of I is 3. The value of j is 2. So 3, 2. A32 is nothing but this particular value. Third row, second column. Again, the value is 1. We'll substitute this value here as 1. So you can see the output here, you can see as 3, 1. Now again, this particular loop, we are still working on this loop. Again, you have entered the value of j. Now, is there further scope of increment of the value of j? The answer is yes, because right now the value of j is 2. You can further increment this to the value of 3. Okay, so from 1 to n, see the value of 3. So now the value of j would be 3. Now here the value of I is already 3. Now the value of j has now turned 3. Again, what is the value of A33? That is 1. So I need to enter value of A33, that is 1. So once that is done, my particular matrix would be formed. So this is how I can ask the user to enter the matrix of his or her choice. Is this clear? Any doubts in this particular looping? MATLAB is full of loops, and that too majority for loops is what we'll be considering for this particular course. So once you understand how we make this particular loops work, then we can move to the other parts of the questions. So what I want you to do is just understand first that how we particularly form this particular matrix. Once this is done, you can simply write this command of BC of eigen A. So here you will simply get B vector B as my what do you say, the eigenvectors, whereas C would be nothing but my eigen values. You just need to simply place this command and you will get the values of eigenvector and eigenvalues. So it's just a simple command, but for that you need to have a matrix A. So let's say in the examination you might be asked to enter such small sort of codes that you need to make a say 3x2 matrix or 2x2 matrix where the values are to be added by the user. Okay, I give you 2 to 3 minutes time. Please go through this particular code again and try to understand that what is being said here. If anyone has any doubts, can ask.
Sir, here there is a line in nested for loop fprintf. So why can't we see in the command window that line?
It is there. It is here. It says enter A. It is already there. You can see it at every step. Here I am entering the values. This is my
Sir,
command window. Here, yes.
sir, command window, I can't see that line that enter the A of 1, 2 and all that.
In the command window, it will not be shown. It is not the input statement. If it is an input statement, you would be seen here. Okay, here, see, here if I write, okay, let's write this again. If say, enter the value for this location, for example. Okay, and if I rerun this, let's say the number of rows again 3, the number of columns again 3, and my value is, okay, see, now it says enter the value for this particular location. Are you getting this point? We had placed this particular thing
Yes,
as
sir.
blank, so that is why it was not being, it was not showing you. If you enter this here, it will be shown. F printf is for your output side. It is not for taking values from the user. Is this clear? So here again, if I enter the value, it was 113. Okay, so 1 year. Again, it would ask you for the value. So again, 1 year, 3 year. Then for the next case, you have 155. Okay, so that is 1, 5, 5. Again, in the next case, you have 3, 1, 1. So this would be 3, 1, and 1. So that is how your entire matrix is formed. So when we talk about fprintf, it would be shown on the output side. But whereas when we want the input, this particular statement will say that whatever you want the user to ask, that okay, enter the value for so and so location, enter the number of rows, columns, or in some other code, if you want the user to ask something else, you can do that as well. For example, let's say I ask you to write down a code where you are asking the user to write their name. So you can simply say that A is equal to, let's say name is equal to input, and then in the brackets you can write enter your name, and then so the user would be asked to enter the name, and then they can enter the name. That is how you can, some simple codes like this. So this will help you to understand that how things run. Is your doubt clear? Just by adding this
Yes, sir.
particular statement, we got that since this is nested, we can get this particular values here. Whatever we write here would be shown here, but it would not be shown on the output side, because here we are taking the inputs. It is not being reflected on the output side. Am I clear?
Yes, sir.
Okay, fine. Thank you. So just another, we just have a 2 minutes break. I want you to go through this and just utilize this time and just go through the code again. And those who do not have any doubts in this, I want you to just search for this particular, or you can simply write your eigen and search that what is it showing here, and then you would see there is a certain syntax, something like this, where you can use any particular variable which would be created a matrix of that particular variable, and where this would give you your eigen vector and your eigen values. So just go through this once. It's a simple basic code. Okay, students, I hope you're clear with this. Now let us move to the next part. What is wrong with this now? Okay. So next, I want you to bring back to your third experiment. Where we have two methods to be discussed. So your practical 3 is to perform the Gauss elimination and Gauss-Jordan elimination method for solving linear equations and validating them with the MATLAB codes and the MATLAB functions. Okay. So here there are 3 set of equations that have been given to you. You can see this. Now I want to solve this using my Gauss elimination method. We'll start with Gauss elimination, then we'll move to Gauss-Jordan elimination. But first of all, if I say I want this to be solved by using Gauss elimination, does anyone know what is Gauss elimination method is? Is anyone aware about Gauss elimination method? Have you studied this before? Yes, no?
No, sir.
No, sir. Okay. No, sir.
Yes,
Anyone
sir.
else?
Yes, sir.
Yes, sir. Who said yes?
Uh,
Rohan?
Hello.
Was it you? Who said yes? Can you try
Yes,
and
sir.
explain? Can you try and explain? The one who said
Sir,
yes?
basically,
Yes, yes.
basically
Go
we
ahead.
have to create a matrix
Okay.
according to the equations, and then we have to reduce the matrix to the identity element matrix, so that we can
Reduce the
get the
matrix
direct value of the x, y, and z.
to get the direct values of X, Y, and Z. Okay. Anything else?
Yes, sir.
Anything else? Anyone would like to add? Anyone would like to add anything? So, okay, in that case, what is the difference between Gauss elimination and Gauss-Jordan elimination method? Would anyone like to answer that?
Sir, in Gauss elimination, we have to create a diagonal element 1, and like elements before diagonal element should be 0. While in
Okay.
Gauss Jordan, we have to create identity matrix only.
Okay. Small correction here. It would not be an identity matrix, because if you talk about identity matrix, the value would always be 1. So here what we'll try to, okay, let me just again explain this. I'll share my screen again. Uh,
Sir, more precise, it should be augmented matrix.
Augmented matrix, correct. That's the right word. Let's say you have a 3 cross 3 matrix. So let's write this as, let's say this matrix is called as matrix A. So let's name this as A11, A12, A13, A21, A22, A23, A31, A32, and A33. Let's say I form a matrix something like this. Okay. Now we had the equations. So if I again come back to the equation, see these are the three equations. So if I make an matrix A that needs to be multiplied with a matrix X, which is nothing but my x1, x2, and x3. Okay, so this would be x1, x2, and x3. And let's say this is equal to my third matrix. Let's call it V, Y, or whatever. You can give whatever name you wanted. That is 13, 20, and 10. So let's call this as the outputs 13, 20, and 10. Now understand this. If I multiply A with X, I get the final value as Y. Okay, so A11 into X1 plus A12 into X2 plus A13 into X3 is equal to my Y1, which is 13. Do you agree with me? Do you understand what I'm trying to say? Yes or no? Everyone, are you understanding what I'm trying to say?
Yes, sir. Yes, sir.
Okay, fine. So now, if we place these particular values based on the equations that we have, okay, so my equation is 2x1. So 2 would be my A11. So this value would be 2. Then with x2 I have minus 2. So my A12 would be minus 2. And with x3 I have 5. So this would be A13 would be 5. In the next row I have 2x1. So my A21, the value would be again 2. The next is A22. So here with x2 I have the coefficient as 3. So here the value would be 3. And A23, that is 4 of x3. So here the value is 4. Moving to the next row, I have my equations 3x1 minus x2 plus 3x3 is equal to 10. So with x1 I have a coefficient of 3. So my A31 becomes 3. Next, with x2, I have a coefficient of minus 1. So my value for A32 would be minus 1. And lastly, I have 3x3. So the value of A33, the coefficient is 3. So this becomes 3. This multiplied with my x1, x2, and x3 would give me the same output as Y, that is 13, 20, and 10. So this thing which I have written in yellow ink, this justifies the same as these equations. Do you agree? Yes or no? This is the same as these particular equations. हाँ कि ना, ये दोनों सेम चीज हुई कि नहीं?
Yes, sir.
Okay, fine. Now, what we do in Gauss elimination and Gauss Jordan is this, that when we talk about Gauss elimination method, we turn this particular triangle of values to 0. So if we turn this to 0, I'll first get, we can solve from the last. So let's say my, I'll first, if this all becomes 0, I'll get the value of x3. So in the last equation, what I'll get is the value of x3. Then this value of x3 would be placed with the coefficient here. And of course, this 2 minus 2, 5, then this 3, 4, and this 3 would not remain same. As in, when we perform this calculations, this value would also change. But first, what I'll get is, I'll get the value of x3. Then I'll place the value of x3 here in this particular equation, where I have only x2 and x3 coefficient, because x1 coefficient we have already turned down to 0. So once I get the value of x3, I'll place it in the equation above. So I get the value of x2. Once I get the value of x2, I place the value of x2 in the first equation and the value of x3 here in the first equation. So when I place my x2 and x3 values here in the first equation, I finally get the value of my x1. So this is how we calculate for the Gauss elimination method. And when we talk about Gauss Jordan elimination method, there we convert this particular triangle and this particular triangle both to 0. So if we convert both of these triangles to 0, we simply have x3, x2 and x1 values available. So here when we talk about Gauss elimination point of view, it's a little lengthier process compared to your Gauss Jordan elimination method. So here, the calculations would be slightly in a way that you will have to find individual values, substitute the value in the other equation to help and find the other component of x. Then use those two components of x that you have found out to find out the third component of x. Whereas in the Gauss-Jordan elimination method, simply by converting these two triangle values to 0, you can simply get the value of A11, A22 and A33, which would be nothing but the values of my x1, x2 and x3. Fine. So now let us understand this and see this in form of my what do you say, my MATLAB program, that how we are solving this. Okay, so first of all, let me start with this, which is my Gauss elimination method. Okay, so I want you to help me and explain the highlighted part which is there on the screen. ये क्या होगा? What am I supposed to expect as an answer to this particular part of the program? Can anyone tell me this? If you want, I can also keep this here so that you can have a look and tell me that what is happening here. Anyone would like to try? हमने जब पहले मैट्रिक्स बनाया था तो उसमें नंबर ऑफ कॉलम्स, नंबर ऑफ रोज, वो सब पूछा था. Here we are not asking what are the number of columns, what are the number of rows. Then what are we doing here? Yes, anyone? Okay, let me remodify my question. Here, what is asked is to find out the number of unknown variables instead of finding the instead of taking the input as number of rows and number of columns. Why is that so?
Because here matrix will be number of unknown variables on the size of.
Because here the matrix would always be a square matrix. Whatever you say is your number of unknowns, that would be the number of rows and number of columns. Because then only, see here again, I'll bring you back to this. This matrix was 3 by 3. Why this was 3 by 3? Because this was 3 by 1. So these are my number of unknowns, x1, x2 and x3. So my this matrix A would always be 3 by 3. My this matrix would always be similar to this dimension, that is 3 by 1. Please understand this. My matrix A always has to be a square matrix, and this dimension of the square matrix, whether it would be 3 by 3, 2 by 2, 5 by 5, 7 by 7, would depend on the number of unknowns in my this particular matrix. Here my X has the number of unknowns is 3, that is x1, x2 and x3. That is the reason I have my 3 by 3 particular matrix here, which indicates this, that this would be 3 by 3. So here again, as we again move back to our screen using MATLAB and this particular, here we have three equations. Again, here the number of unknowns are 3, that is x1 and x2 and x3. So here I give my number of unknowns as 3. So the value of n is stored as 3. Okay. Now once the value of n is stored as 3, I am running this loop from I1 to 3. So what does I and what does j indicate here? Can anyone tell me? Just read the highlighted part of the program and please tell me what does I and what does j indicate here? Or what is I representing and what is j representing? Yes, anyone?
Rows and column respectively.
Yes, rows and columns. Your I is representing the number of rows, whereas j is representing the number of columns. So your first, your I is from 1 to n. So in the first row, my j is representing the number of columns. So I'm taking the input from the user and forming my matrix where j is from 1 to n plus 1. Now see, we were forming a matrix where, as I said, that we are using a square matrix. So in that case, this j should also be 3. But instead of 3, now the j is from 1 to n plus 1. So that is 3 plus 1, 4. Now, why is this happening? So this is happening is because we are forming an augmented matrix, as someone said. So what is an augmented matrix? So an augmented matrix is nothing but a combination of this matrix and this matrix. So here your augmented matrix looks something like this. This would be 2 minus 2, 5. Then this is 2, 3, 4. This is 3 minus 1, 3. And you usually write augmented matrix something like this. And then here you write 13, 20, 10. But since you cannot draw this particular line in your MATLAB, so we simply take this as 3 rows and 4 columns, where fourth column is nothing but my Y matrix, which is being added to this particular part. Okay. So again, moving back here, okay, let me just run this so you have a better idea. Okay. So the unknown variables that I'm entering is 3. Now it asks me that I need to enter the value. किसके लिए value enter करना है? For I and j. Now initially my I is 1, my j is also 1. Now if I see my I is 1 and j is 1, so the value of A11 would be 2. So see here, as someone asked in the last question, here I am getting a question mark. Why? Because I have not asked what is the value at this particular location. So question mark, so I just simply need to add my answer here to the question mark, which is nothing but 2. Sorry, not here, here. That is 2. Fine. Then the value of j is done. You have entered the value. It has been asked. Then you again reach at this particular end. Now from here, again you move back to this for loop. You see an increment in the for loop. So from J1, you are moving to J2. So now the value you are asking is I still remains 1, J becomes 2. So you are asking the value for A12. Is this clear? Can you see it on the screen as well? The next value is being asked is A12. So that would be value of A12. Now this is minus 2. So I write here as minus 2. Similarly, again, further increment in J. So now J turns from 2 to 3. So the value that I'm asked for is 1, 3. And at first row, third column, the value I have is 5. Again, this is not from 1 to n. This is from 1 to n plus 1 because we are making augmented matrix. So for n plus 1, what we'll see is that this part, that is your n plus 1th value is your 13. So this value would be 13. So what you see is 2 minus 2, 5 and 30. Now we are done with 4. With the value of j is equal to 4. Now we cannot go for j is equal to 5 because j needs to be from 1 to n plus 1 only. So this loop is complete. Now you come to this particular end. Once you move here, again it moves to the for loop here. And it says from I is equal to 1 to n. Your 1 is done. Now we make the value of I, we increment this to 2. Again, you can write as seen in the last program also, you can write this as 1 colon n or directly 1 colon l. It is the same thing because MATLAB takes the default value of incrementation as 1. Okay, so this is how you can use this for this particular matrix. Okay, am I clear? So once you do this, you have reached the second row. So for 2, 1, that is second row, first column. Again, the value is 2. So the value here is 2. Second row, second column, the value is 3. So here the value is 3. So you can see this. This is being, if you can see my cursor, you can see the value is being added here. Then for 2 comma 3, the value is 4. So let us add the value here as 4. So you can see for 2 comma 3, the value of 4 is added. Now I am asked for the value of 2 comma 4. So for the second row, fourth column, this, since you are forming an augmented matrix, your fourth value of the second row, fourth column value of the second row would be 20. So you just add simply this. Now again, you have run this loop from 1 to n plus 1. Okay. So again, for I is equal to 2, you have completed this entire process. Now you further need to increment the value of I. So now when you further increment this value of I, you get this as I is equal to, now it is 3. So once it is 3, again you repeat the same process. So for 3, 1, for the value of A31, it is 3. For A32, the value is, this coefficient is minus 1. The coefficient of x2 is minus 1. So we write this here as minus 1. Then we have the coefficient of x3 as 3. So this becomes 3. And finally, the coefficient of the third row, fourth column is 10. So here the coefficient becomes 10. So this is how I have entered the entire matrix here. So we have reached till this particular point. So this ends my entire this thing where I have to enter the number of rows. First of all, the unknown, then the values of each row and column. And finally, I am forming this particular matrix. Any doubt so far till this particular point? Anyone has any doubts? This is the repetition of what we have just done. Now, what we need to do is we need to convert this particular matrix. Now, understand, see, I want this value as 0, I want this value as 0, I want this value as 0. So, let us first convert this value as 0. Now, how can I convert this value as 0? So, if I want this value, but I don't want these two values. So I need to multiply this value with something and add it here so that, or say this value, my first row, first column value with something and subtract it from my second row, first column value so that this becomes 0. Okay. So for that, I need a particular factor as per my program. Now let us understand that how does this factor come into picture. So here, let us come to this part. So for k is equal to 1 to n, for I is equal to k plus 1 to n. Now understand, as we have said that whenever we are running any particular operation on a matrix, we'll have always have two loops. One is the outer loop and other is the inner loop. Your outer loop would always be for your rows, whereas your inner loop would always be for your columns. So here in the inner loop, your initial value of k is 1, your value of I is equal to k plus 1. So value of k is already 1, so value of I becomes 2. Okay. So factor is A21 divided by AKK. See, here the value of I is k plus 1, initial value. Okay. But this is running under this for loop where the value of k is already 1. So here the value of k is 1, but here the value of I becomes 2. Okay, so I2 k1. So A21 divided by A11. That will give me my particular factor. Now let's again come back to the matrix that we were. So A21 is this, divided by A11 is this. So this will give me a factor which is 1. Is this clear? ये factor सबको समझ में आया? Now what we are doing with this factor, I'll make you understand this. But are we clear how did we get this particular factor? Any doubts till here? Anyone? Any doubts so far? Okay, fine. No answer, so I presume that there are no doubts. Now, what we are doing is, why did we take this factor? We took this factor because now what we are doing is from j to k of n plus 1, what we are doing is aij is equal to aij minus factor into akj. Now, understand this very carefully. Your value of k is 1. Your value of I is 2. Now here we are taking a third variable which is j, which would be helping you. See, I want to subtract this by multiplying it with something and adding it here to make this particular point 0. Okay, so my 2 by 2, my factor is 1, so I need to multiply this with the factor that is 1 and subtract this from this. So 2 minus factor multiplied by this value would ultimately turn this term to 0. Okay, so once my factor has been decided, what I'm doing is, see, understand here, my I value is 2, j value is 1. So here 2, 1, see here, when I keep my cursor here, it is showing me the last values. Okay, but right now here what we are doing is my I value is 2, j value is 1. So A21, this particular value would be, this is 2, 1, which was initially 2, minus my factor value is 1 multiplied by my AKJ, where my K value is also 1 and J value is also 1. Okay, so that is this. So 2 minus factor value is 1 multiplied by the value of A11. So this turns out to make my value of A21 as 0. Any doubt so far? Are you understanding how we got this particular value? Now we have run this particular loop to find out, to make this particular value 0. But now, since this says that this is a loop and j needs to run from k to n plus 1, here the value of k was 1. Now we further increase the value of j. So now from 1, the value of k which was 1, now we increment it by 1. So now the value of k is 2. So now at aij, that is 1, 2, sorry, not 1, 2, but 2, 2, because I value is already k plus 1. So A22, that is this particular value, would be 5. See here, this particular value would be, we have already turned this to 0. Now we are performing some operation on this particular value. So that is A22 is equal to A22 minus factor which is 1 multiplied by AKJ. AKJ is nothing but my value of k is 1, value of j is 2, so that is 1, 2. So 3 minus factor is 1 and multiplied by this term, that is minus 2. So 3 minus 1 into minus 2. So that is 3 plus 2. That gives me my answer as k is equal to, sorry, this particular value of A22 is equal to 5. Is this clear? Is this clear? Yes or no?
Yes, sir.
Okay. So if this is clear, I want you to perform this particular expression on the entire matrix and tell me that what would be the final matrix. Here what we have done is we have done it till this particular point. Now I want you to solve this for till j is equal to n plus 1. So what would be the value here and what would be the value here is what I want you to find out. Instead of 4 and 20, what are the new values that you get? Please calculate and tell me the answer. Anyone? Anyone would like to answer?
-1 and 7.
-1 and 7. Okay, fine. So first what we are getting is -1, which is correct. And again we run the loop once, and what we get the answer is 7. Good. So once we are done with this loop is complete. So now we further increase the value of I from k plus 1. 1 plus 1 2 था, अब उसका 2 का अब 3 हुआ. Now when the value of I is 3, so what would be my factor? Now for calculating the factor, again come here. Value of I is 3. So the factor is 3, 1. That is this. Correct? My 3, 1 value is 5. Yes or no? Yes or no?
Yes, sir.
No, my 3, 1 value is 3 and not 5. My 3, 1 value is...
Sorry, sir.
Yeah, no problem. But see, this question was asked because I want people to pay attention. See, here I am further incrementing the value. So my 3, 1, the value is 3. Now the factor is, see, for the factor, this is the formula. So 3, 1 divided by 1, 1. Okay, so 3 divided by 1, 1, the value is 2. So 3 by 2, and that is how you get your factor as 1.5. Now once you have got the factor, एक बार factor मिल गया, then again you enter into this particular loop where it says, now for k which is still 1, so 1, 2, n plus 1. So you are taking all the rows. The value of I, which is now 3, 3, 1. So that is this is equal to 3 minus factor is 1.5 multiplied by the value of 1, 1, which is 2. Okay. So this would make this particular value as 0. This is now turned as 0. Now you further run this particular loop again. So ये तो 0 हो गया. What would happen next is you are multiplying, you are incrementing the value of j. So now the value of j is 2. So aij, I is 3, 3, 2. So this 3, 2 value would be nothing but -1 minus the factor is 1.5 multiplied by this particular -2. So -2 multiplied by 1.5 and added to -1. So this will give me my value as 2. Again, further calculating this for my third and the fourth column, I get the values as -4.5, -9. So once that is done, again this loop has been complete. I further want to recalculate this. So once this is done, I again calculate my factor with this particular increment of k. Okay, so that gives me my factor of now my value of I is 3. So again factor is 3, 1 divided by 1, 1. So again that gives me my 0.4, and that is how you again further you do this. So finally what you get is this particular thing. So this is the matrix that you do you get after substitution of all these things. Now this matrix is the same as this particular matrix when you perform all this particular task and you have turned this part as 0. This has also become 0. This has also become 0. This has also become 0. So now what you have landed here, you can see that these three values are 0. So now if I want the value of x1, x2 and x3, I need to make a variable x which is a matrix of n comma 1, where n is the number of unknowns, that is 3 rows and 1 column. So that is how you'll get a column matrix x. Now here initially I have made this entire matrix as zeros. So all the values in this 3 comma 1 would be zeros. Now since I've taken this as zeros, now I can add values here. So for x of n, now see here the value of n is 3. So I'm not starting by placing the values of x1, then x2 and then x3. No, I'm going in the reverse format. What I'm doing is I'm first placing the value of x3, then I'll place the value of x2 and then I'll place the value of x1. So I'm going in the reverse order. And why I'm going in the reverse order? Because I initially cannot find out the value of x1 from this particular last matrix that you can see of A. I can find out the value of x3 from here. I just simply need to divide minus 12.3 divided by minus 4.1. That will give me my value of x3. Once I get that, I can place it in the above equation, which is nothing but 5x2 minus 1x3 is equal to 7. So once I get the value of x3, I place it here, and from that I can get the value of x2. Again, after I get the value of x2, I can place the value of x2 and x3 both in my equation number 1 here to get the value of x1. So similarly here, what I've done is I've made a column matrix with 3 zeros. The next what I've done here is I have started adding from the bottom, as I just suggested, at a of n comma n plus 1. Now understand this, a of n comma n plus 1. So n is 3, n plus 1 would be 4. So a of 3 comma 4. So 3 comma 4, that is minus 12.3 divided by a of n comma n, that is minus of 4.1, would give me my answer as 3. Is this clear? This is how this particular line is being calculated. Now once this is done, I am going for another sum. Now why I am doing this is because I want to move to the upper part as well. Now for the upper row, I need to substitute the value that I've got into this and then take it on the right hand side to get the value of x2. So that is what I've done in terms of my loop. For I is equal to n minus 1 colon minus 1 1. So I am moving from n minus 1 to 1 with a decremental step of 1. Minus 1 indicates decremental step. Here my n value itself is 3. So 3 minus 1, so I am starting from 2. With minus 1, I will go to 1. So this loop would be run twice. Here my sum I have taken, since I don't want my MATLAB to pick up any garbage value. So that is why I am stating that right now my value of sum is 0. So initially, if you can see this workspace, there is a variable which has been called as sum. So initially this particular value would have been 0. Then when I run this, it says j is equal to I plus 1 to n. Now again, here, what is the value of I? N minus 1. So 3 minus 1, that is 2. So 2 plus 1, again 3 to 3. So here, what is my sum? Sum is equal to sum, which was initially 0, plus aij into xj. Again, what is the value of j? Is 3. So xj, x of 3 is 3. And multiplied by aij. What is aij? That is 2 comma 3. So I need to multiply this minus 1 with my value that is 3. So now my value of sum becomes minus 3. Once this has been minus 3, what I do is my xi, that would be a into I into n plus 1, where I is 2 and 2 plus 1 becomes 4, minus sum divided by aii. So this would ultimately give me my second value of x, because my I here is 2. So x2 would be found out. So that would be a of 2 comma 3, that is 2 comma 3 minus sum, which is minus 3, and that is further divided by a 2. So once you do that, you finally get the value of x2, which is nothing but 2. And lastly, you further run this loop to find the sum again. So you further increment this particular thing and repeat the entire process. So my sum becomes minus 4, and then further you calculate this. So your sum value would be further updated to 11, and once that is done, you further substitute to get the value of I is equal to 1, that is from n minus 1 to 1. This is the third time we are running this, and my xi value turns out to be 1. And that is how you can find out this particular entire this values of my x. So my now final matrix x, which I had taken as 0 0 0 as my column matrix, after calculation and substitution of the values, my final matrix x turns down to 1 2 and 3 as the values of x1 x2 and x3. Is this clear? I am again showing you the screen. Please go through this particular program, and please ask if you have any doubts. I have already shared this program file with you. You can simply just use this code and run in your MATLAB, and please run this step by step so that you have an understanding that how this calculation is being performed, what values are taken, and it is doing the same way as you do it manually. So your task would be, you need to write down this particular numerical, solve it manually as we do it with our normal this thing, using pen and paper, using normal mathematical formulas. You'll simply, again, you'll use the same method, of course, you'll not use any other method. You'll use this Gauss-Jordan method only, sorry, Gauss elimination method only, uh, and solve this. Also, you will form a flow chart that what is done, and after one part, what is the second part that is being done, what is the, so it's everyone understands the flow chart. I believe that once you do this, you need to make a flow chart for this particular method. Also, when we talk about this particular subject, I have already shared 5 experiments with you. I'll share a couple more with you as well. I want you to form that particular file, attach your handwritten this thing. What do you say? The numerical solved as well as the flow chart. File it up, and you'll have to submit that to me. So that is what is required from your end. So any doubts here so far? Any doubts in the Gauss elimination method? If yes, please ask, or else we'll move to Gauss-Jordan elimination method. Okay, fine. Let us move to the Gauss-Jordan elimination method. Again, we are using the same set of equations to find out the answer using Gauss-Jordan elimination method. Here, again, using this particular set of commands, you are forming your matrix, or let's say you are forming your augmented matrix for the unknowns to find out their values. Since we are using three equations and we have three unknown variables, the value of n would be 3. Once this is done, we'll move to this next loop. Once you have formed the augmented matrix, we'll come to this part. Now you have to tell me that what are we doing here? In this entire loop, what are we doing? Go through it. I'll give you 2 to 3 minutes time. Please go through this and then we can discuss. Okay, welcome back students. Anyone would like to try? Anyone? Okay, fine. So let us move back to the code and let us try and understand what is it trying to say. So now initially we have the value of k is equal to 1 to n. So initially the value of k is 1. So the temp is a variable which has been created and it stores the value of k. Now the value of k is 1. So it stores the value of a11. Now this is the matrix that has been formed. So value of a11 is 2. So that is why the value of temp is considered as 2. Further moving from j is equal to 1 to n plus 1, akj, that is 1 1, is equal to akj by temp. Now akj is nothing but value of k is 1, j is 1. So this akj, that is this particular value, needs to divided by the temp. Now the temp is the same value, that is this 2. So this will give me this particular value as 1. Okay. Then in the next part, what I'm doing is again I'm dividing the neighboring value, because since we are moving in the first row and the rest of the columns that we are doing. So for the next row again, I need to divide this -2 by temp, which is 2. So this will give me my value as -1. Similarly, the next value is I have 5. So 5 divided by 2. So this would give me 2.5. And lastly, I have 13 in the last row. So again, that divided by 2. So this gives me a final value of 6.5. So by this, I complete this particular J loop. Now, for I is equal to 1 to n, now see, understand this. It says for I is equal to 1 to n, if I is not equal to k. Now, initially, my value of k is 1. Now, here the value of I is from 1 to n. So, initially, since we are running this loop for the first time, the value of I is also 1. It says if I is not equal to k, then the value of constant is this. And for that, you have to do this particular operation. But this is not the case in my case, because my have I and k, both the values are same. So I'll not be performing this. So I can simply skip this part. So from here, I just need to, we have done this, and then I don't need to do this part. And then again, I come back to the next point where I see an increment in my I. Okay. So if I further increment the I, so now my value of I is 2. Now my I and k values are different. Now my I is 2 and the k value is 1. So if that is not equal, which is my case, so if this is true, my constant value is a2 comma 1. So what is the constant value here? So that would be taken the constant value as 3. Yeah. Okay. So now, again, what I need to do is constant value is 3. Now, from j, from k is equal to where k value is still 1 to n plus 1. So that is again 4. I need to do aij is equal to aij minus constant into akj. So that makes this particular term 0. Then again, what I am doing is aij. Now I'm incrementing the value of j. So what I can see is the change here. the value here is -1. My constant value is 3. So what I'm doing is I am doing -1 minus 3 into this -1. So 3 into -1 is -3, and that -1 minus 3. So that is -1 plus 3. So that gives me my answer here as 2. Again, in the next step, my this 3 would change. Why? Because this would be 3 minus 3 into 2.5. So that would give me my answer as minus 4.5. The last would be 10 minus my factor is 3. So 10 minus 3 into 6.5. So that becomes minus 19.5 plus 10. So that gives me my final answer as minus 9.5. So this is how my entire loop is run once when my I is not equal to k. Now once I have completed this, I'll again come back to this loop where I increment the value of k. So now my value of k is 2. So for the value of k to be 2, see, I have just a second. Yeah. Okay. So I have reached the value of 2. So k to 2 would be my next temp. Just a second. This was the first case. We calculated this. Here we come to the. So this was done. Now here my A22, that is this particular value 5, becomes my new temp. So my temp is equal to 5. Next, for j is equal to 1 to n plus 1, I am calculating my value of k is 2, j is still 1. So at a2 comma 1, so this is 2 comma 1. So 0 divided by my temp, that will again be 0 itself. Fine. Then the next is I am dividing this 5 by 5, that would be 1. The next is I am dividing minus 1 by 5, that gives me 0 minus 0.2. Then next I am dividing this 7 by 5, so that gives me the answer as 1.4. So this is how my this entire loop for dividing with temp is now over. Once that is done, I move to the next constant. Now, how do I find this constant? So, for I is equal to 1 to n, now the value of I is 1, but the value of k is 2. So, now since these both are not equal, so constant is 1 comma 2. So, what is the constant 1 comma 2? So here you can see the 1 comma 2 is minus 1. So that is why from there my constant turns out to be minus 1. Okay. Now once I have found out this constant, again what you do is for again the value of k is 2. So from 2 to 4, what we are doing is aij, that is 1 comma 1 is equal to 1 comma 1 minus the constant multiplied by the kj. Again, you need to perform this for all this particular thing, and again set the constant again and run this entire loop. So this is how when you solve this entire thing thoroughly, so that finally what you'll come and see is you are seeing 3 zeros here, and all this the principal diagonal elements have turned out to be 1, and similarly you will see zeros above the principal diagonal and below the principal diagonal. So that is how you can calculate this. Once that is done, you come to the later part of the program, that is printf the solution of the given linear equations. For I is equal to 1 to n, you display. Now here you are creating a you are displaying 1 comma n plus 1. Okay, so first row n plus 1, that is 3 plus 1, that is this one that is displayed here. Then print fn, so that comes to the next line. Again you move back to the same for loop where now your value of I is 2. So a 2 comma n plus 1, so again second row n plus 1 is again the fourth place, that is the value is 2. So this again 2 is printed, and next again is print f, that is slash n, which brings you to the next line of printing. Again you move to the for loop for the last time, where now your value of I becomes 3. So then display a of 3 comma 3 plus 1, that is 4. So 3 comma 4, that is this particular value. So the value is 3, which is further printed here. And that is how the entire numerical gets solved. So in the Gauss elimination method, what you are doing is you got this x3, you used to substitute it in the above equation, then you used to find out x2, then you further used to substitute x2 and x3 both in the first equation, and then you would be able to find out x1. But here you can simply find out your x1, x2 and x3 using this particular method. So this is how this particular looping works. Any doubt so far? Anyone? Okay, fine. So if you do not have any issues with this, I'd like to end this here. And I also want you to practice this. First of all, I would request you to just solve this mathematically, which will revive your concepts of Gauss elimination and Gauss-Jordan method. Once that is done, try to try to make matrix which are user defined. So you take the values from the user and try to make the matrix. Once that is done, then get into the mathematical operations for calculating Gauss-Jordan and Gauss elimination method. Fine. So I want all of you to practice this, and we do have a session tomorrow as well. Okay. So please practice this and come, which will help you for tomorrow's session as well. Any doubts in today's session, please ask. If not, I would like to tell you your final examination of this particular subject is on 29th. That is next to next Friday, 29th of March. So we would be having your examination on 29th of March at morning 9 o'clock itself. Okay, where you would be asked to write small programs. You might be asked to build a matrix. You might be asked to write a program for this Gauss elimination, Gauss-Jordan. The other things could be you are given a program, okay, you can type that and you have to find out that error, that what is the problem in this particular code, why is it not executing. So that is also one way we can modify the particular questions for your exam. But examinations is one point where we'll be taking up such questions. But what I want you to do is please practice this particular coding. and then only you will be able to code this for examinations. Also, there are certain very small commands that we did today, like eigenvalues and all. Please practice that as well, so you have an idea that how such things are put into action, and how these particular codes work. What is the correct syntax for that? How you write this particular code so that it gives you the correct answer. Okay. There might be a case where your code is being executed, but the answer generated is not correct. So that also needs to be validated. So here what we are doing is I'm asking you to write to solve this particular numerical and write down on a piece of paper and punch it with your files. The reason for doing this is same, that I want you to understand the coding as well as I want you to validate the answer mathematically as well. Fine. So that's it from my end. If you don't have any doubt, we can end the sessions. So one last time, any doubt so far? Okay, fine. In that case, you are free to leave the lecture. Thank you so much and have a great day.